Hi there. Most AI agents today are really good at generating answers. But in real workflows, the problem is not generating text. The problem is getting fresh, structured data from the web. If you ask your agent something like, find me the latest pricing of this product, or summarize the content of this particular website, it generally struggles because it doesn't actually have access to the web in a structured manner. So in this video, we want to show how we can fix that. We are going to take an OpenClaw agent and give it real-world capabilities like scraping, crawling, and answering questions using live web data. And for doing so, we will be building a custom plugin for OpenClaw with the help of Olostep. So by the end of this video, you'll learn how your agent won't just talk, but actually go out, fetch data, and use it in real-world workflows. So let's start with what we are actually building. We're building a custom OpenClaw plugin that gives our agent web data capabilities. Here's what that means in practice. You ask the agent a question. Instead of guessing or hallucinating, the agent can scrape a web page, crawl an entire site, retrieve structured content, or generate answers. So the flow would be the user asks the question, the OpenClaw agent then uses the plugin tools and calls the Olostep API, which fetches the web data, and the agent finally generates a response. And the key idea here is that we are not really modifying OpenClaw itself, but we are extending it through the plugin ecosystem within OpenClaw, which means that the agent becomes much more modular. And why this matters is because of the fact that tools are really the most important aspect of the real world agentic systems. Without tools, your agent is just reasoning inside of a vacuum. With the right set of tools, your agent can become a researcher, a scraper, a monitoring pipeline, a data pipeline. And web data is one of the most important capabilities because every real world workflow depends on external information. And that is why this integration really matters a lot. So we are not just adding a feature, we are making the agent much more web aware. Let's also quickly discuss about OpenClaw. So OpenClaw is not just a chatbot framework. It's designed to build agents that can use tools, interact with services, run workflows, and plug into real-world systems. And the key feature here, as we have already described, is this plugin system. So instead of modifying the core OpenClaw system, you can add functionalities through plugins, which means you can define your own tools, you can register them, and the agent can start using them as part of a workflow that you have defined. And that's exactly what we are doing here. Now, in order to look at what our plugin does, we'll also first talk about what exactly is Olostep. So Olostep is basically a web data API for AI systems. Instead of building your own scraping infrastructure, you can create pages, crawl websites, search the web, generate answers with sources. So instead of having to worry about custom scraping logics, proxies, or parsings, you're internally just calling an API. And that is what makes it perfect for agents, because now you can focus on the capabilities and not the infrastructure. So before understanding from a code level, we'll also just talk about what does the plugin architecture look like. So here's how the plugin works. An OpenClaw plugin is a small Node.js project with 3 parts. So we have package.json, which contains all the dependencies and config. We have the OpenClaw.plugin.json, which contains the plugin metadata. And we have index.ts, which contains the actual logic. So inside index.ts, we initialize our Olostep client, we register all of the different tools, and we expose these tools to the agent. And once the plugin is installed, these tools behave like native OpenClaw capabilities. So let's talk through each and every different individual file and what role it plays. So first of all, in the package.json, we define all of the project metadata, dependencies, and OpenClaw specific configuration that is needed to make the plugin work. So here we declare the plugin name, we set the project to use ES modules, and we point OpenClaw to the index.ts entry file. It also defines the compatibility requirements for the plugin API and the gateway version so that the plugin can load correctly in your local OpenClaw environment. Next, we have the OpenClaw.plugin.json. So this is essentially your manifest file. You define the plugin metadata and expose any configuration that should be editable through the OpenClaw dashboard. The ID in this manifest should match the plugin name that is defined in package.json. The config schema that you see tells OpenClaw what configuration values the plugin expects, with UI hints control how these values appear in the dashboard. So in this case, the Olostep API key is exposed as a sensitive field, so it can be entered more securely. And the UI hints section controls how the API key is displayed on the OpenClaw dashboard, including the label, placeholder text, and the sensitive input handling. Now let's talk about the entire logic of our application, which is index.ts. So with the plugin files in place, the next step is to actually define what's the behavior of the plugin inside of this particular file. So this is where OpenClaw would basically load the plugin's entry point, initialize the Olostep client, listed the different tools that will be made available to the agent. So this implementation is built around the OpenClaw plugin SDK. So using the SDK, you can define the plugin entry, access the plugin configuration, and register each and every different tool with its own name, description, parameters, and the execution logic. So since the Olostep API key is already exposed through the manifest, the plugin can read the value from the configuration and use that to create the Olostep client and when the plugin is loaded. So our plugin will rely on two main dependencies. One is OpenClaw and Olostep, which will interact through the Olostep SDK. So we start by importing Olostep, the OpenClaw plugin helpers, and the typebox utility used to define our tool params. Next, we have the plugin entry, which is defined through the define plugin entry. This is where you register the plugin metadata and expose the register method that OpenClaw will call when loading the plugin. Here, we also register or initialize the OpenClaw client inside of the register method. Now, with the client ready, the final step is to register each and every tool that the OpenClaw agent will be able to call. Each tool is registered through the API.registerTool function, where you define its name, the description, the parameters, and the execution logic. The first tool is going to start a scraping job for a given URL using the Olostep scrape API, and it returns the scrape ID. This is useful when you want to use the agent to extract content from a specific page and then fetch the results separately once the job has completed. Now, the next tool that we have is get scrape content. So once a scrape has finished, the next tool can be used to retrieve the scraped output. So this allows the agent to pull back the cleaned content once the completed job has done. Then we have the answer tool. So this tool allows the agent to ask a question and receive a response generated by searching and validating web content along with the supporting sources. So this is really useful when the goal is not just collecting raw page data, but searching through answers using the web as a knowledge base. Next, we have the crawl tool. So unlike the scrape tool, which focuses on a single page, the crawl tool starts a broader crawl job across the website using the Olostep crawl API. So this is useful when the agent needs to collect information from multiple pages on a domain rather than extract content from just one single page. And it starts the crawl job and returns a crawl ID. And then the next function would be, after starting a crawl, it's useful to check its status before retrieving all of the collected pages. So this tool hands that by returning information about the crawl job. Then we have crawl pages. So once the crawl is complete, the final tool can be used to retrieve the pages and content collected during the crawl. So this gives the agent access to the actual site data gathered through multiple URLs. We run npm install in our local project directory to be able to install our two dependencies, which are Olostep and OpenClaw. Next, we go ahead and do OpenClaw plugins install, which will allow us to install the plugin locally so that OpenClaw can recognize it as part of your environment. Because the plugin is being installed from the current directory, make sure that you're using the command from the root of the project where you have the package.json, openclaw.plugin.json, and your index.ts files where they are located. Next, what we do is we go ahead and restart our OpenClaw gateway after installation so that the new plugin can be loaded properly. So this step ensures that OpenClaw refreshes its environment and picks the latest newly installed plugin. Without restarting the gateway, the plugin may not appear or may not be usable straight away. We can also just take a look at our gateway status to ensure that it's running. And another thing that we can also do is we can also run the plugin's inspect command to ensure that the plugin has been installed correctly and is showing up. And next thing that we'll do is we'll just go ahead and run OpenClaw dashboard to launch our dashboard. So once the dashboard is running, navigate to the automation tab and do remember to set your Olostep API key. This is required for the plugin to authenticate with the Olostep API. And you can see here that we have the Olostep OpenClaw tool. So just ensure that your key is already set. Now, once you have already set the key and you have saved the changes, you can always go ahead and test the tools. So our next step is to see how the agent actually uses these tools in practice. So for example, in that case, what we'll do is we'll go back to our dashboard now and start to interact with the agent. So with the plugin configured, the next step is to test how the agents actually uses these new tools in practice. So in this example, we'll now open the OpenClaw dashboard and we'll ask the agent to scrape the Olostep website. and summarize the content. So as soon as we give that, we will start the process and we'll be able to see in real time how it actually starts to utilize this. So immediately what you'll see is that it uses the scrape tool and to scrape the job for that given page, and it can call the scraped content and then return the specific ID. So here it gave us the scrape ID to retrieve the cleaned content of that particular page and return the result to the user. So it used the next tool, which is to get the scrape content, and it started to give us an entire summary of the entire page. So here you can see the specific tools that it used. So the scrape tool and then the get scraped content tool from our plugin, as if it is natively part of OpenClaw. So now we can also test the crawl workflow. So we can give it that also crawl the same website. So it will basically start to use the crawl tool and then check the progress with the help of the get crawl info. So if the crawl is still running, the agent can basically return the current status rather than trying to fetch incomplete results. So now it will start to run this entire step. So here, you can find all of the different crawl results that were all the page URLs. And it did that pretty quickly as well. So it's using the sequence of all of the different relevant tools in order to get the response that as requested by the user. So what's the conclusion? OpenClaw is a really versatile tool, and the plugin system makes it straightforward to extend what your agent can do. So in this tutorial, we explored how do we push these boundaries by integrating Olostep API to search, extract, and structure web data, giving the agent the ability to scrape, crawl, and extract structured data from websites. So when you combine OpenClaw's extensibility with capabilities such as web search, scraping, and crawling, the agent moves beyond being purely reactive and becomes genuinely useful in real workflows. So you can build research agents that autonomously gather and synthesize information, or systems that continuously monitor the web and deliver updates directly into your chat app. Once you understand this pattern, you can really just integrate almost any external capability and extend what your agent is capable of doing, building an AI that actually does things for you. So thank you so much.